Okay, let's see if we can get through this one. They want us to use cylindrical shells to find the volume of a solid obtained by rotating the region bounded by, that's what the green is, 6x squared minus x cubed, and y equals 0 about the y-axis, okay? So what do we got to do? We have to figure out, well, we have our volume equals for a cylindrical shells method. Here's our integration that we have to do. And remember, I always remember the shell radius is the distance from the axis of revolution. So our axis of revolution is the y-axis. So it's the distance to that form. So I picked a particular point on that curve, and there's this particular shell that I picked out. And here's the height of the shell, and here's the radius of the shell, right? So the radius goes from here to here. The height goes from here to here. Okay, so, and another trick I always remember, if you're rotating around the y-axis, get the interval in terms of x. If you're rotating around the x-axis, get your interval in terms of y. It's kind of the opposite. So that's why I wrote dx. So we want to get everything in terms of x because we're rotating around the y-axis. Okay, so first of all, let's figure out what is the height. Well, I think we can just go. We can just go. The volume equals, okay, what? We're doing this in terms of x, so we have to figure out what our x values are going from. Well, I think you can see they're going from 0. How come I got an x is 6 there? That's where if you put y equals 0 in and solve for x, you would get 6, right? Makes sense, right? So it goes from 0 to 6. You got 2 pi. The shell radius is the distance from the axis of revolution, so it's a particular, what? X value, so it's just x. And what's the height? The height goes from here to here. It's from the x-axis into the height to the function, so it's just the function, right? That's the height right there. The height is 6x squared minus x cubed dx. The hardest part is plugging into these things, figuring out what to plug in. The integration is the easy part, right? Okay, so what do? Let's integrate, okay? So let's see. The first thing I think I'm going to do is put the 2 pi in front. It's going from 0 to 6. And I think I'll distribute the x. So what do we have? 6x cubed minus x to the 4th dx. Is that correct? Right? Okay, so I just have to take antiderivatives, right? I still have the 2 pi sitting in front. What's the antiderivative of x cubed? Isn't it 1 over 4x to the 4th? What's the antiderivative of x to the 4th? 1 over 5x to the 5th. All between 0 and 6. Right? So, this is not too bad. So it's 2 pi. Don't forget that 2 pi because I tend to do that. 6 times 1/4 times 6 to the 4th minus 1/5 times 6 to the 5th, right? Minus, again, it's 0, 0, right? So basically you have to do this right here. So I got 2 pi 1944 minus 1555.2. And I got, when I did it on my calculator, because I think they want decimal, this is what I got. Okay, so maybe the thing that I didn't really go over is like to find out that x is 6, you would have just set that equal to, right? You'd set that equal to 0. And then what did I do? I factored out an x squared, and you get 6 minus x. And then set each thing equal to 0 with that 0 property rule. So you get x equals 0, x equals 6. That's how I knew that was x equals 6. And that was x equals 0. Okay? All right, so I hope that helps. Good luck with that.